Today I am going to discuss about application of the SR latch, a switch debouncer. Switch debouncer. Debouncer. Okay, so for interfacing keys to the digital systems, we use push button keys. These push button keys, when pressed, they bounces a few times, closing and opening the contacts before settling to a steady position. So this is a problem, and this problem is known as a key debounce. Okay, so what happens when push button keys are pressed, bounces a few times, closing and opening the contacts before settling to a steady position or steady reading. So this problem is known as key debounce. This problem is known as key debounce. Okay, so let us see actually what is this key debounce problem. We are taking a battery and of voltage V, and we have got a switch, we have got a key which has two positions, A position and B position. Now key is currently at the B position. Okay, so this is B voltage currently at B position. So VB voltage is high currently. Okay, fine. So when the key is at B position, A position obviously it is at the low. That is VA voltage is a low voltage. Okay, fine. Now we changed the keys. Now the key position is changed to A. Therefore, VB voltage has become low. So already VA voltage is low. When the key position is changed to A, VA voltage has to go to high position. Okay. How it goes high? After few debounces. See here. It is not instantly going to high position. After few debounces, it is going high. So this is which is nothing but these bounces, key debounce problem. It is key debounce problem. Say for example again after that VA. Now we changed the key position from A to B. So that means A voltage has come to low. Now VB voltage is supposed to become to high position. Now also instantly it won't go to high. Again after few debounces it is going to high. This is what the key debounce problem. How to avoid this key debounce problem? This key debounce problem is avoided by SR latch. So what we will, and SR latch, and that circuit is known as, and the circuit is called switch debouncer. Switch debouncer. Here, see, we are using SR latch, Q bar, and the same key setup we are using here, which has got two positions. One position is connected to S and the other position is connected to A. R. No. This is A position and this is B. When key is at position B, S equal to 0, R equal to 1. Therefore, for SR latch, Q equal to 0, when key is at position A, S equal to 1, R equal to 0, therefore Q equal to 1. Okay, fine. Now, when key is in between, that is between 0 and 1, in between, that is when in that debounce region, then what happens? The output does not change as SR latch retains previous state when S equal to 0, R equal to 0. So, when the key is in between, which means A equal to 0, B is also equal to 0. Which means, that means S equal to 0, R equal to 0. When S equal to 0, R equal to 0, it retains the previous state. Okay, so this is how, hence, key debounce problem is avoided. That means the voltage either it is high or low. That's all. So there is no the debounce problem. It cannot be in the middle position, because when the key is in between, what happens? The key positions itself, A equal to 0, B equal to 0, which means S equal to 0, R equal to 0. When both are zeros, it stays in the previous position. Okay. Thank you.